So this afternoon in the technical track one, we're going to have a GenAI hands-on session, which will be led by Marvin and myself. So please give a round of applause to welcome the Google developer advocate, Marvin, to come on stage. Thank you.
Good afternoon, everyone. Good afternoon. I hope you're doing well. Are you enjoying the session so far? Are they exciting? All right, I can't hear the guys at the back. Can you hear me? All right, so thanks so much for joining. My name is Marvin Ngesa. I am excited to see all of you here today. And even as you join, I think we all need to be attention. So attention, everyone, because in this session, attention is all you need. So, and we need attention because there's this paper by Google called Attention is All You Need. And it was released by Google researchers in 2017. And this paper contains how something called large language models, I'm not sure if you heard about it, can be taught to pay attention to certain words of the input sequence, almost the same way that a human being can do pay attention to these words. And this made it possible for us to be able to have long sequences, and it solved the memory issues that the previous models had. And this paper has been a game changer in AI, because without it, today, you won't go to that interface that you use to chat with the large language models. And of course, today we're going to take you through introduction to what GenAI is, then probably take you through how to write prompts, different kind of prompts, and then take you through a hands-on of Gemma open weights model. But even with the prompts, all of us are going to write prompts today. This is going to be a hands-on session. And what that means that all of you should have your laptops ready, open them, fire them, open the laptops, make sure they have power, and then search something called Google AI Studio. Just run it as I take you through the presentation so that when you're ready, also your Google AI Studio is ready. Who is excited? Are you guys excited? All right, so my name is Marvin Ngesa. My background is electrical engineering. I am very passionate about signal processing and autonomous systems. I'm currently working on a research called multi-agent reinforcement learning. And you can think of it as having different agents in a controlled environment, like the one we have here. Agents in one corner, another agent in another corner, another agent in another corner. And then these agents are in a controlled environment, like this room here today. But these agents are able to interact with each other with the goal of maximizing their reward function. So there's no controller, but these agents work together, but with the goal of maximizing the reward function. And they work in a kind of decentralized manner. I'm also a good developer expert, and we have a nice community called Nairobi AI, where we discuss a bunch of stuff about GenAI, deep learning, agents, etc. And of course, I know that you have been chatting with these chatbots. Which one do you know? Which one do you use? So every single time you interact with these interfaces for those chatbots, if you put a chat here, behind it, there's something called a large language model. And of course, this can be an interface. Behind it, there's something that does reasoning for you. Behind it, there's something that does maybe planning for you. I'm not sure if they do planning today. Do they? Do they do planning? And then we have memory and context as well. But the web that you use is not the only interface. There are also other nice interfaces like what you can see on the screen, where you can have a robot, where the input for the robot will be a video or an image. I mean, you can have a multimodal kind of model, like Gemini, for example, and get inputs, process it, and then get output from it. But still, even in this one here, you still have prompts, the one you're going to take you through today. So you don't just have prompts if you're building a chatbot. You can even have a prompt with a robot somewhere. So I was just giving you an outline. So today you're going to go through GenAI 101, then you're going to meet Gemma. My colleague is going to talk more about Gemma. But myself, I'm going to dive deep into how to write good prompts for your large language models. And then we'll do some hands-on session. I hope you've already opened your Google AI Studio on your browser. Just fire it up so that when we get started, you don't have to open it afresh. Just search Google AI Studio and then log in with your Gmail account. So that's the outline for the session. Of course, you've been hearing about AI, machine learning, deep learning, GenAI, large language models, and all that. And probably you're wondering what's the difference between all this kind of thing. So what's the difference between AI, what's machine learning, what's deep learning, what's GenAI, and all that. So if you can teach a computer to behave almost like a human being, and then you put this thing in a computer, then it's AI. And what I mean is that human beings are able to sense the environment. You can sense the environment. You can touch. You can smell. Beyond that, you can also reason from what you're sensing. And then if you touch something and it's hot, you stop touching it, yeah? You can act and then even adapt. So if you have a program that can sense, reason, act, and adapt, then that's AI. But under AI, you also have, I'd say, algorithms, which could be a big term in this room, or even a function that if you provide it with more data over time, its performance increases. If its performance improves, if the performance of a function or an algorithm improves, if you provide it with more data and more time, then that's machine learning. And machine learning is under AI. And then deep learning is where now you have a bunch of neural networks. Don't worry about that. I'll show you what that is. And then you have also a large kind of data. So a subset of machine learning in which you have something called multi-layered neural network that can last from a vast amount of data. That's deep learning. But just to bring it home, if you see at the top, do you see 1, 2, 3, 4 to 7? And then you have values of the first x, then values of y is 7, 14, 21, 35, 49. What will be the next one? Yeah? How did you get that? Yeah? Because you got that because now you've known that there's a mapping between x and y, and that mapping is this one here. And if you provide more values of x, if you had more values of x, the data, and you can have more values of y, and you can map the two, then that's machine learning. I don't know if I'm oversimplifying it, but if you have this kind of thing, a function, or you're having an algorithm, that performance can improve. If you give it more data, that's machine learning, over time, of course. And of course, today we have something called predictive machine learning, where in this one here, I can say if you have 8, what's the next number? If I have 10, what's the next number? And that's predictive ML. But you can reverse the entire thing so that still, you map the frequency distribution of the data that you have, you map the x values and the y values, and to a point where it can produce new content like images, audio, video, based on the distribution it was trained on. Then that's GenAI. Okay, of course, while machine learning is a broad field that encompasses many techniques, deep learning is a type of machine learning that uses neural networks, allowing them to process more complex patterns than machine learning, as you can see on the screen. And then under deep learning, we have GenAI, which I've told you what it is about. And under GenAI, we have something called large language models. And in large language models, ideally what you're having is that you are having neural networks that are trained on large data sets. Then you have a large language model. And neurons from a linear unit, you can call a linear unit neuron. But let me not go into more of that. Let me go into the exciting thing. And of course, these large language models are general purpose. The general purpose. What that means is that you can train a dog on key things. They can know how to sit, how to stand, and how to do that. But if you want a special kind of dog that can be at the airport and sniff bags and all that, there's something you do to this dog, yeah? There's something you're doing to this dog. There's some special kind of training you're giving the dog. And those are the kind of things we're going to look today. Of course, that's fine-tuning, but we won't check on fine-tuning today. We're going to check on prompt engineering. And if you talk about large means that these large language models are trained on trillions of data. You have parameters like 1.7T, 340B, etc. And you also have multiple GPUs on them. And of course, there are a bunch of these models, which my colleague is going to talk about. And I won't go more into that. I'm going to focus more on effective prompt engineering. So how many of you write prompts day to day? Of course, all of us. Who hasn't gone to Gemini today? Or the other one? Have you guys gone to the other one or Gemini? All right, so you'd say a prompt is an information that you pass to a large language model to kind of elicit its response. This includes task, data, history, instructions, examples, and even more. And that's the key areas to write a prompt. Of course, I know you have that some of you just write maybe a one-line prompt, but other people write long prompts. In my laptop here, I have a prompt that is almost 200 lines, which is a prompt. But these prompts, they have some key things into them. So one thing is persona. You have to you can give it a name, yeah? Task, what are you supposed to do? Context, yeah? Because these models are trained on global knowledge, yeah? But would you want to give it context for, let's say, Nairobi or Lamu or Aria, for example, this hotel? So you need to give that context and format, and then it now be able to behave almost like how you want it to behave. For example, if you see on my screen, you are a Google Cloud Program Manager, that's persona. Draft an executive summary, email to, that's the task you want it to do. Based on about relevant, that's the context. Then the other one is the format. So that's how you get started. You have persona, task, context, format. And all of us are going to try this today. So I hope your studios are up. How many of you, who has opened their Google AI Studio? Who hasn't managed to open? All right. Of course, you're going to iterate this over and over again, but the key thing I want to take is that with prompts, they're just more into prompts than just the one line that you write. You need to define a task for it, like the example I've shown you. Define a tone for it. How does it respond? How should it, if it's a prompt for a customer service and a prompt for someone telling stories to kids, will they be the same? So the tone will be the tone of, let's say, a solution telling kids a story will be different with a tone for a service chatbot for customer support. So you need to change that tone. Of course, provide background information. The two will be different in that one as same. And you can even tell this large language model that, you know what, when someone talk to you, this example to follow when they talk to you. If you follow this example, you'll arrive at the right answer. If you follow this example, you'll end up at the wrong answer. So you give it examples on how it needs to behave. Of course, it's good, it's powerful, it knows all these things, but can you give it you can show it examples that this is how to do my task, this is a step-by-step process of doing the task, and if you follow this method, you'll always arrive at the right answer. But if you follow this other one, be sure you'll have a wrong answer. All right. So I think let me just jump here so that we go to the exciting parts. So the key things to the prompt, I've talked about the user, the persona that you put to it. You need to be clear and direct in providing your instructions, and provide role. I've talked about that already. You can even use tags just to organize your kind of prompts with examples. I'll show you how to do that. And I think I want to go here. Here. So, have you opened a Google AI Studio? All right. Also, I have a GitHub repo somewhere here that I want you guys to be able to access. Because we're going to do like hands-on in this session. Who's ready for a hands-on session? All right. So I think that I'm going to do it. I want to just tweet it, then you get it from Twitter, then you put it there. So this is the lab we're going to go through. our first lab, but to share it and make it easy, so this is what I'm going to do. Let me just tweet it now. I don't know a good method to do this. Let me just do this. Is it that one? $2024, yeah? All right. So just click there, then take you to the lab, then open that another tab, then we get started. I hope you, yeah, or just search that and you get it. If you've got it, let me know. Open Google AI Studio one side, the lab on the other side. Okay. So if you open the lab, you should see, oh, okay. First of all, who is there already? You've managed to open the lab, yeah? Okay. Who else? Who hasn't managed to get the lab? You've opened the lab? Have you? Perfect. All right, so let's get started then. So the first thing you're going to do is that this is a way to write a prompt, a guide to write a prompt. And then on the other side is an example of the prompt. In my case here, you can see you are a well-renowned, then a role. You understand how to write, etc. That is appropriate for etc. That's the example. But on the other side, that's the guide. But on the other side, there's example that adds what's missing on it. I'm sorry about that. But I have this on the lab. You don't necessarily have to use this. If you check on the lab, we are on step 1. And actually, this is my example. That means that you need to come with your own example. I'll guide you, but you come up with the example. That's okay? Are we together? Who is? All right. So what I'm saying is, are you on the repo? Oh. Okay. Let me go back to the repo then. So first of all, just ensure you open this. Yeah. I've tweeted it. Just go to ODHS to 24. Probably it's like the first things there. Then you'll be able to open it. Who doesn't have Twitter? Yeah? Or you can just search online and just search 254 GitHub. Just do this. If you don't have Twitter, just do this. 254 GitHub. Then just search that. I think it's the first one here. Are we together? Who is left behind? I think that one has all the lab. And guess at 254. NGESA 254. GitLab. Yeah. Okay. Oh, just go to Nini here. Oh. Yeah. 254. GitLab. And then, just run it. Then when it's coming, let me know. Okay. Are we okay? Are we good? All right. So once you've done that, So we're going to start with the first thing. That's a persona. And if you see on my lab here, so this is how it looks like if you go to the lab. And then the first thing here is define task, stroke persona. So for example here, you are something. So this is just a guide. Then you come up with now your prompt. You need to come up with your own. But you can use the example I have here. So you are a something. You can say me, I've filled it. You are a senior, this one, architect, with then expertise in specific domain. I'm now defining tasks for it. With extensive experience implementing health information system in Africa. You understand how to design interoperable health solutions that are appropriate for low resource settings and align with WHO guideline. So with that alone, you defined task and persona. Once you define that, please don't submit it to Gemini yet. Just have it. Don't submit it to Gemini. Don't submit it to Google AI Studio. Just have it written down. So here is a template. I've just filled the role on my side and the task on my side. And here you can see the example I have. And you can have your own as well. You don't necessarily have to use mine. Just ensure that you have the task and the persona. Oh, but then can you guys see, or should I increase the screen, the size? Is it okay? Is it better? Yeah? Or now it's worse? All right, who's done that? Who has done that step? Am I fast? Or am I slow? Am I okay? All right, this is what I said. One, first of all, open Google AI Studio, one side, yeah? Once you open it, don't do any other thing. Just ensure that you are logged in. That's step one. Step two, go to my GitHub repo, and I hope you managed to get it. If you didn't get it, just type on Google, Ngesa 254 GitHub. Yeah? Once you've done that, navigate to this, labpromptengineering.md. Yeah.
If you're having trouble accessing anything, just raise your hand. I'll come and help you. I've got a QR code for the repo, so if you want to scan that as well, I can come help you.
Yeah. Nice. The exact line, yeah? All right. Perfect. Oh, someone has done a good job here for us. Made it easy for you guys to access the lab. For guys who haven't accessed the lab, and thank you so much. Let me just go here to ensure all of us are on the same page. I think he's replied to this. Let me just reload it and make it simple for all of you. Now we have a code for the lab. Yeah, just scan the code now, then go to the lab. Who hasn't accessed the lab? You can just scan it, then go to the lab. Okay, are we okay? Who hasn't managed to open the lab? So we have the lab in the Google AI Studio, yeah? Are we together? Have you eaten? Are we together? Are you sure? I'm not sure if. All right. Okay. So I hope you have something like this, for example. This is my Google AI Studio. I've logged in. I'm ready. Don't worry about all this. We'll set all that together. Don't worry up to this point. Now I want us to just focus on the prompts that you're going to write. And then also, I hope you are now here. Once you scan, and we are on step number one. And step number one, we are defining the task and the persona. And I gave you a template with something like a role here that you need to add. But you need to add like a role and a task. Define the task and persona. And I have an example here for my side that you are a senior health HR architect with extensive experience implementing health information systems in Africa. You understand how to design interoperable healthcare solutions that are appropriate for low resource settings and align with WHO guidelines. So that's my prompt. Feel free to have yours. Don't submit that yet, just have it. Who has that already? Ah, nice. 2 minutes. 2 minutes is long, man. All right, okay. You ready? Don't submit it. As we give them 2 minutes, let me just tell you what's next. So the next part of it, we are going to set the tone for our. So remember, do not submit where we are at the moment. You've defined task, persona, don't submit. Then you're now going to go to the tone. So, okay, let me wait for you. Step 1, task. Step 2, tone. Also, let me show you another one here. This is just another exciting one. Maybe this is another person, and they're saying this is their own kind of task and persona, and they're telling the model, you are a well-renowned children's book writer. You understand how to write children's book that are appropriate for ages 6 to 10 in a fun, engaging tone. This is an example. This is another example. Feel free to have yours, but just ensure that you have a task and a persona. Are you guys okay? Are we good? We are good, yeah? All right. Then the next thing we're going to do is that you're going to add tone to it. For example, just maintain what you had, and then now you are dash with this kind of. So for example, on my side, you should write in a tone that is ra 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 ra, but that is a template. So on the example here, you are a senior. We've done that already. You should write in a tone that is technical yet practical for implementation. That's my tone. So also you add the tone to what you had. You should write in a tone that is technical yet practical for implementers. Then you add this part. Can you give me 5 ideas for implementing offline capable FHR systems for rural clinics in Kenya where internet connectivity? Just add that last line once you've added tone to your task and persona. When you're ready, once you're done that, just raise your hand so that I see. Are we together? Yeah? Task, persona, and now tone. We're good? All right. So once you have that, now add this last line. Can you give me 5 ideas like that? Then drop it drop it here. So in my case, systems, I think I had that already. So I'll take this for my case. Let me just copy here, actually. Just copy that, come here, then drop it here, then run it. So you can see it's running live. You can see number 1, hybrid approach with local data storage. Number 2, mobile fast, that. Number 3, that. Number 4, that. Number 5, that. And I wanted just 5. So we've started our prompt engineering. It's like an iterative process. We now have a task. We now have a persona. We've added tone to it. And then now we submit it to Gemma. Oh, before you submit, I forgot something. Are you seeing my left side? Yeah? Ensure you have Gemma 2B model, because this is an open source model on the left side. Left or right? On the right side, on the model, just add Gemma 2B there. I hope you haven't, oh, okay. I'm on Google AI Studio. You can see, this is Google AI. Oh, when you open Google AI Studio, just accept, read them, then accept. I'm not sure you read all of them, but once you accept, just go to create a new prompt, yeah? Then once you create a new prompt, just go create a new prompt and let me know if you're there. Let me walk around and see what you guys have. But ensure on the model side, it's Gemma 2B. Gemma 2 to B. Okay, just checking. Are we together? Ah, nice, 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 nice. Gamma 2B. Gamma, I'm not sure. I think it's Gemma. Nice, nice, perfect. So once you have, remember, don't submit with just, don't submit with just task and persona. Make sure you have task, persona, and tone together. How is it, by the way? So far? Is it exciting, Emma? It's boring. All right. Okay, I can see a bunch of guys are there already, which is a good thing. Okay. All right. Yeah. Yes, Gemma 2B. Just scroll down. Again. Yeah, this one. Yes. Okay. All right. I can see most guys are we are with you together. So what you're going to do is that you're going to copy this response and flesh it out. So, do you have power? Okay. All right. So, pick that response. So, the response that you had, yeah, this response here. So pick from number 1. Okay. Okay. So we want to make it open-ended. Let me see. So we want to make it open-ended. Means that we want to flesh out some part of the example that we had, and then have it be more creative with us, and even give us kind of more content to it. So. Why is it? So what you have, the first examples that you have, so for example, in my case, so this is the response I get. You can see, okay. This is the response I get, but it's full. 3, it's written all of it, yeah? So at this point, I just want to add 3 dots. 3 dots, then implementation, I start from up to somewhere here, flesh all this out, add 3 dots to it, then go to somewhere like within, then add 3 dots. We want to flesh out some parts and make it more creative to get us more meat into the story. Are you getting me? All right, so this is what we have, yeah? From number 1, number 2, number 3, up to number 5. This one here. So copy this one somewhere, like that. For example, here in VS Code, then paste it here somewhere. Then once you've done that, we want to flesh out some pieces of this story. Like this first one. So the concept, so like somewhere here. Just remove this, and then like that, yeah? 3 dots. Maybe this, somewhere here. 3 dots, just like that. Then we give it back to Gemma again and see how creative it will be on that. Are we together? What you have, just copy it somewhere, add some 3 dots to it, just flesh out some things, then just to see how more creative it can be before you continue to the next step. Is it exciting? Okay. So just like that again, like that again, like that. Yeah. So, yeah. Um, yeah, just where you feel. Just it doesn't have to be, because we want to see how creative it can be, and what more thing it can give us. I think let me. Okay. Let me remove this for myself so that I can get UL. Just flesh out all of them. So at the end of it, you see this example here, number 2. So this is just an example of how you can flesh them out and remain with the key parts. Because at this point, you see this one was like an entire story, like an entire feedback after toner and ideation. And then now you flesh it out. And if I flesh that example, this is what I have. Of course, I know you have a different example, so you'll have probably something similar to this one here, if you flesh it out. Yeah. So who is there? Who is there? Okay. Or I think probably what we do is don't flesh all of it, just pick one. I think it's like a lot, yeah? Instead of 1, 2, 3, 4, 5, just pick one, the one that you are excited about. Then flesh out the other parts. Then, once you've done that, we're going to add more background information to what it's given us, because it's giving us a general answer, yeah? It's giving us global knowledge, but you're in Nairobi. We don't know, I'm not sure if it's from UK or from London or from New York. We want to rail it and ground it with more information from Nairobi, yeah? So flesh out those things and then give it some kind of meat from Nairobi, some kind of context from Nairobi. Just be creative and say, give it some kind of context from Nairobi once you've removed all those ones. For example, if I was writing that kid's book, you can see I can, for example, in this case here, this step 2.2, I already have the feedback here, the long response with the five ideas, but now I flesh out the lot of things from it and have it this way. Then once I flesh those things out, I now ground it with my kind of, I'm making it more appropriate for my location. Yeah. So once you are in step 3, let me know. Are we together? Yeah? Okay. Once you have the 5 examples, pick your favorites. Either one, it will give you like 5 of them, yeah? Pick your favorites. Leave the other 4. Just pick one. The one you pick, flesh some parts out, yeah? By fleshing out, this is what I mean. So these, you could say, this could be your feedback, yeah? Like 1, a long story, 2, a long story, 3, a long thing, 4, a long thing, yeah? But maybe all those things it's given you, it's not relevant to your context, yeah? So what you're going to do is, you're going to pick one story. For example, in my case, you can see I've picked this one here, this one here. And once I pick it, I come with it down here, yeah? Where is it? Here. Then I flesh out the other parts. You can see that this is what from all that in number 3, this is now what I have. Yeah? It means that it's given me ideas, nice ideas, but I'm not connected to those nice ideas. And I want to, because those ideas are from maybe New York or Cape Town or Lagos, Nigeria, or China, but what I'm building is for Nairobi. What I'm building maybe is for Lamu, yeah? So flesh out those other parts and remain with something like that one. For example, I chose example number 3. Then once you've done that, now we're going to kind of rail it to content from Nairobi or content from Lamu or content from wherever you are, wherever you're coming from. And then you could see I had this number 3, but I've added like 1, 2, 3 things up to 8 on what I was writing. You get the point? Are we okay? Do this if you're okay. Are we lost? Which table should I go to? All right, that table. Which other table? Oh, 1, 2, okay. But how is it? Or we are lost? Or I'm lost? Okay. You have internet? Some information about Kenya, what is global, what you're watching. To the point. Yeah. Maybe number 1, number 2, number 3, number 4, number 5. You get. Yeah. Exactly. Yeah. Yeah. No, I add things that are relevant. Up maybe of 10, my 8 that are relevant to where you are. Okay. Yeah. That makes sense, yeah? Yeah. Okay. Which other table? We are good in this table now. Here. All right. I'm just going snake like this. At the next table? Okay. Personal. You okay? We are good? Okay. This one. Now, now we want to relate to our example. But what that means is we want to give it more what? More context to our locality. So fill in something that's relevant to where you are. Just fill it at the end here. Just write something. You can just maybe even here, add more dots, or even down, just in any way. Okay. Something? Yeah. That's okay. Almost at 1 hour. Yeah. 2:30. Yeah. So 3:40. 3:40. In 20 minutes. Okay. Correct. Yeah. Just give it another instruction. No, another instruction. Just see. Just fill in the blanks with your context. Just be creative and say, okay, give it the context of yours. That's Nairobi of it, or that company USness of it. Okay.
This just like
Yeah. Yeah. Okay, are we okay? Are we good? All right. Are we okay? Are you sure? It doesn't look. Anyway. All right. So what you're trying to do is you're trying to rail the GenAI into each thought process. Of course, the first thing you do, let me just walk you back. I hope you've been working with us. Is first of all have task and persona. You didn't submit. Just add task and persona. You didn't submit. Then you added tone. Then let it ideate for you. Let it give you imaginations. But the imagination it's giving you, some of them are wild. Some of them you can't relate with them. Some of them are from New York, but you're in Nairobi. So you're going to pick one example, either number 1, number 2, number 3, or number 4, or number 5. Once you pick it, then you're going to flesh out some parts of it. For example, you can see this one here, 1, 2, 3, 4, 5. Just pick one example, and then bring it somewhere here. For example, this was my example here, number 3. Once I pick it, then I bring it here and add more context to it. You can see now I have 1, 2, 3, up to 8 on what I was having. But with just one example, I'm adding more context to what I'm having so that it can ideate even more for me. Yeah? Then now this is what you submit. Again, For now, more thinking, but now with your context. So once you have those examples, what you added to, so let me walk you through again so that we are together. The first thing you did was task and persona. You didn't submit, you did not submit. Then the next thing we added was a tone to it, then you submitted it. But in that tone, remember, you told it to give you 5, where is it? On this lab, can you give me 5 ideas for what you're having? Yeah? But these 5 ideas, remember you have a tone, you have a persona, you have a task and tone. Then ask it to give you 5 ideas. Then when you get the 5 ideas, you are going to pick one idea out of the 5. Then that one idea, you're going to flesh out some parts because maybe they're not relevant to where you are. And once you flesh them out, you're going to rail it now with more context of where you are. Then now, what you're having, let me check here. So ideally, you're just adding background information to the entire thing. Then once you've done that, don't submit yet with that. You can also give it rules before you submit. So you flesh out, add your context, railing it down, don't submit yet. We're going to add rules to our prompt. Are we okay? Are you following? Persona, task, the next one, tone, and then pick idea, yeah? Pick one single idea, flesh out some parts, then add your parts that are relevant to what you're having, and then now we're going to add rules before we submit. Are we okay? All right. So, for example, here I have a rule that so, like in my example here, the rule is that each of the sections should be a paragraph long, as they should be okay, just forget about that. My rule here is the paragraph should be written in a roller coaster style. They should have a moment of surprise, excitement, twist, and turns. The tone should calm down as the action dies. But that's my rule. Feel free to have your own rule in the prompt you're writing. Yeah? Remember, once you add the background information, now we're adding rules. We're together, yeah? So you got 5 results, you picked one, fleshed out some parts, and added background information to it. Then once you do that, don't submit, yeah? Add a rule to it. Add a rule to it. For example, in here, my rule here, for example, I've said is the paragraph should be written in a roller coaster style. They should have a moment of calm, surprise, excitement, twist, and turns. This tone should calm down as the action dies down. But that's mine. Or the other one here, remember you added examples here with details. And then, yeah, don't think I added that one here. Anyway, it's fine. Just add a rule to it. Like here, okay. Anyway, it's fine. Have you done that? You've added a rule, and once you add a rule, then now just submit. Remember, you've added background information, then you add rules, then now you can submit. Are we together? Let me walk around and see. Are we together? We're good? Okay. You can check it. You can refer to the GitHub repo. Yeah. Oh, and if you're stuck, you could just check what I have on the GitHub repo. You could see like the description of what you need to do, what I've done, what you need to do, what I've done, how I added my tone, how I added my persona, how I added my background information. Yeah. And once you have the rule, just submit, then it gives you like new kind of ideas.
Then I took it here, and then I flashed.
Okay. Anyway, once you add other rules, I think I have like 5 more minutes. Let me just go fast a little bit. So once you have the rules, the next thing you're going to do, you're going to submit, get a feedback from it. Then you can give it examples. And if you give it examples, this one now is called N-shot prompting. N-shot prompting, that's the techniques. But it's a big word. That means provide examples to the prompt you're writing. In my example here, for example, you see, I have an example here as a tag. See that one? So that's N-shot prompting. So for example, in there, as the tractor was flying through the sky swoosh, a big, angry bird flew past, almost knocking Grandpa hats off. Just an example I've added there. Or in this other use case, just to bring it home, you can see here I have an example. Here's an example of how the implementation should work. Yeah. So the example in a tag, you can see here, when a healthcare worker opens the app offline, they should be able to view existing patient immunization records, record new immunization using FHIR immunization resource, queue changes for sync when connectivity returns. Just give it an example of how it behaves, what you're having. Just an example, and put it in an example tag. Then once you've done that, don't submit yet with example. We're going to go to step 3, thinking. You can also tell it how to think, and you can just copy exactly what almost what I have, and tell it how to think. Like in my case, take as much time as you need, think in steps, and build up to climax, then resolve down. Place your thinking for each chapter in thinking tag. So I'm telling Gemma on how to think. And if I go here, for example, this is how mine should think. Think through this step by step and consider what FHRIR resources are essential for minimum viable functionality. How will data be synchronized when connectivity returns? What validation rules to work offline? Place your thinking for each component in thinking tags. So you add thinking, show it how to think. Then after that, what's remaining is just specifying the output format for what you're having. Like in my case here, I'm telling it that write the book in a markdown with each chapter clearly named. At the end, add an abstract that can be used on the outside of the book. That's one example. The other example I have on the repo is write the technical specification in markdown format with clear headline for each section, code example in appropriate blocks, architecture diagram if needed, include an executive summary suitable for presentation to the Ministry of Health stakeholders. That's now the output format. And then at that point, you'll have specified the format of what you're working on. Then now you can submit. And then with that, at least you'll have gotten started with how to write a prompt. So I can see it's already 3:40. I want to thank all of you for listening to me. This is a photo generated with something called Stable Diffusion with GenAI. It was someone like in Kisumu, something like that. I call it Onyango. So it's from Stable Diffusion, but we call it Stable Onyango. Anyway, thank you so much for listening to me. I hope you enjoyed the session.
All right, thank you, Marvin. Thanks. Where's it? Oh. No, it's okay. I've got it. Thanks again, Marvin. So for the second half of the session, I'm going to talk a little bit about open models. We have learned a lot about sort of GenAI, large language models in general, and prompt engineering with my hands-on experience. So I'm going to talk about open models and specifically Gemma. We're going to go through a little bit of an exercise as well in the middle, and then at the end, I'm going to show some of the work we have done with Gemma with healthcare guidelines. Right, so a bit of intro about myself. I actually studied artificial intelligence and computer science, which kind of I conveniently forgot about the AI part for many years until very recently. So this was many years ago in 2007, I was working on a robotic project. So I wrote my first sort of convolutionary neural network that does kind of like robotic mapping stuff. And my master thesis was actually also about AI. It was to do with theorem proving. But since 2020, I've been working on Open Health Stack, and I'm really excited to be applying some of my experience and knowledge to the health field. So open models and Gemma. First of all, open models, what are they? So when we talk about open models, it's really about the democratization of AI, right? It's about giving sort of free access to large language models to a much wider audience. So, obviously has lots of benefits, such as fostering innovation and collaboration. We'll talk more about it. So there are different types of open models, actually. Not all open models are equal. There are open models that have the weights open, so you can download these models, run these models as you wish. But there's also fully open models which have their model architecture and the training data even available. So there's different levels of openness, I guess. It's not surprising. Some of the examples include Google's Gemma, obviously, Llama, Falcon, and Bloom. Let's dive a little bit deeper into the benefits. There's quite a lot of them, obviously. So first of all, transparency and trust. I think having the models open really gives people an opportunity to really look into the details of it, include the training data and algorithms, potentially leading to more responsible AI development. Obviously, AI risks and responsible AI is a very big topic, and people are really worried about applying AI in certain domains. So I think open model has a benefit in this area, clearly. Having models open also encourages or improves reproducibility. I think yesterday it was mentioned that if you use Gemini or ChatGPT for your research, there's no way for you to verify that after a while because the model will be updated, and then when you call the API, the results will not be the same. But that's not a problem with open models because you really take control. You have the full ownership of executing and running the model in your environment. You can customize open models. You could fine-tune, for example, Gemma. You could collect data and then make Gemma perform better in a certain domain, for example, healthcare domain. So that's another really big advantage of open models. With some of the big models, you don't really have this option. Privacy and control, very important, especially, again, in the healthcare domain. You are not really sending your data. You have the option to really running the open models locally in your own environment, even on the phone. So you're really not losing control over your data. You're not sending it to OpenAI or Google or anyone else. Data security and compliance, these are also really, really big and important topics when you're working with sensitive data. But open models give you these opportunities of having more control and really sort of reducing the risks of data breaches. So the last comment, also really important, you can run Gemma on Android. I think this is a particular interesting use case, especially when we talk about some of the rural areas where you don't have very good connectivity. I was actually trying to build the model on my phone, but sadly, I broke my old phone and I'm trying to run a new one, but it's not working right now. But I was ambitious enough to try to do that in the sort of about an hour's time when Marvin was presenting. So sadly, I didn't get it to work. But I think it really shows how easy and quick it can be, right? Because literally, I just downloaded Gemma 2, which is like 2 gigabytes, which is quite good, quite big. But I downloaded it onto my phone, and then there's like an example app you can try to run. So if you're a developer, spend half a day on this, you could get a model running on your phone and working in your application. Right, so those are the benefits, but there are also challenges. I think accuracy and reliability is a big topic, right? Because the models that are open source are typically smaller. They're not really the top line sort of like large language models like the latest Gemini or ChatGPT. So the performance, understandably could be less. A bit worse than those models. So it's very important to prevent misinformation and misuse. And I think this is a very big topic as well, but one sort of common term we hear is that we want to have a human in the loop to double check the result of the model. So sometimes you may not want to expose the model's answers directly to the end user, but maybe you use that for something like education and training and help your health workers to provide a better service to the end users. Cost, if you decide to host your own open models in your own environment, you have to think about the cost. Obviously, there's also considerations around continued maintenance and support, and when there's model updates, how do you keep up with the latest models as well? Right, so kind of just talking about JAMA really quickly. I actually didn't know that there were so many different flavors of JAMA until I was going to present this, and I stole this slide from Marvin. So there's the original JAMA, there's cold JAMA, recurrent JAMA, which is good for sort of time series data, polyJAMA, which is a multimodal JAMA, so you can pass image data to polyJAMA. JAMA 2, obviously shield JAMA is which I only just learned yesterday, which is a security sort of specific JAMA model. And then JAMA scope I think it's for you to look into the model a little bit more. I don't really know the details. So if you want to learn more and possibly know more about JAMA than I do, go and take a look at the JAMA site, obviously. There's plenty of information and performance benchmarks. So specifically about JAMA 2, that's what we're going to play with a little bit later on today. It is the latest model. There are two versions, 9B and 27B. So the number here represents the sort of number of parameters that's tunable in this model. So 9B, the smaller model, 27B is the bigger model. And it has a context window of 8,000 tokens. So one token is one token is a bit more than a word. So, sorry, one token is a bit less than a word. So the 8,000 token context window translates to around 6,000 words. So you can pass a reasonable amount of content to JAMA, but you can't pass huge documents to it, if that makes sense. Yeah. And then you can explore the model, the models, the different flavors of it, on either AI Studio, which we will do, or Hugging Face and Kaggle, which are some of the platforms that host the models. Right, so before I move on to the sort of next section of this, I want to spend a bit of time and ask everybody to spend a bit of time, again, in AI Studio with JAMA 2. So I have a QR code here. I just created this repo. You can use either the link or the QR code to go to my repo called ODHS. Did I get the order right this time? Open Digital Health, yeah, that's right. Hyphen GenAI. So when you get to the repo, you will see that there are some sort of synthetic patient personas that I have generated, right? So my ask to everybody here is that I want you to use those personas and then pass those personas to JAMA as part of the context, which we have learned from the first half of this session, and see what JAMA can do with that data. Right? Some ideas include maybe you can ask JAMA to figure out what health conditions those patients have. Maybe you can ask JAMA how they can improve their health, what advice you would give them. And then you may ask JAMA if they need to seek doctor's help on anything, or any other questions you want to ask the model. And once you're done with that, I really encourage you to try different models, right? You can try the latest Gemini and see if Gemini gives a better answer, or if you have a ChatGPT on your phone, feel free to chat with ChatGPT or any other model. So I'll leave the screen on, and we'll spend, I think, maybe 5 minutes or so, 5-10 minutes. So yeah, let's get going. So as I said, the context window is an important consideration. So when you're passing the data, the patient's profile to Gemma, think about like how much you can pass to Gemma, and if you're going to be limited by the size of the context window. I see that a lot of people are trying to answer some of the questions. Can I ask 3 volunteers to share what you have done with Gemma with the 3 patient profiles? Maybe 1 patient each. Any fundings on? I think we have if the internet is working. Oh, there we go. Anyone used Gemma to find out what's going on with Hiroki Tanaka? Did anybody try this profile? Yeah. What did you ask Gemma and what did Gemma say?
Okay, so we basically ask Gemma for general analysis of the client, put in their data, and the recommendations from the clinical findings. We have elevated blood pressure and cholesterol levels. We have an ECG that is non-specific, STT wave, with a recommendation that the cardiovascular risk reduction should be done via medical adherence and lifestyle modification, stress management, and regular monitoring.
Wow, thank you. A round of applause for Gemma. But do you trust it? Is it right?
80-20. I'm giving it 80.
Yeah. Okay. Internet's not working again. Yeah. I can't remember the name of the second patient. Can someone remind me? Or did anybody get some interesting results?
Yes, the patient was called. What was the name of the patient here? Amina Juma, right? 25, and I put the profile and I asked, given the above patient profile, what conditions does the patient have, and should they seek any doctor's help or any remedy? So I was given the response. She has iron deficiency, which is anemia, and the symptoms, the diagnosis and the treatment that should be done. Then some potential complications because she's pregnant, and then the iron deficiency might cause some long-term health issues. And then there was, since I asked for a remedy, there was suggestion for addressing the challenges that included diet and supplementation of iron. Then the recommendation, Amina should absolutely seek medical attention. Her symptoms are consistent with iron deficiency or anemia. And early diagnosis and treatment are crucial for her health and for her unborn child.
Great, thank you. Cheers. Right, hopefully everybody has tried this example and has got something out of it. Right, let's spend a few minutes to have a bit of a discussion on this, right? So first of all, I think I want to say what you have done there was great, but also really dangerous, right? we have just asked the model to provide a medical advice on based on patient's profile. So we have to be really, really careful about things like this. In no way I'm suggesting this is a way to build medical applications. So don't just do this and push it out to the field. Please don't do that, right? So right, let's go through some of these sort of discussion topics, right? Did anybody try Gemma and compare the results with either Gemini or maybe other models? Did you find out anything interesting about it? You can still try now, by the way. So I think there was a comment about sort of it being 80-20 in terms of the accuracy of the result. I mean, I'm surprised it's that good, actually. You know, it could be, you know, sometimes it might be better, sometimes it might be worse, depending on how complicated the case is. I've played with it quite a bit myself. I found it to be a bit flaky. Sometimes it's better, sometimes it misses some very important points, right? So I think the point here is that, you know, you can't fully trust it. It is very useful. It's very good at summarization, understanding the basics of the profile, but you cannot fully trust it. So especially, you know, when we are building healthcare applications, you know, there's a huge responsibility to provide accurate information, and we have to not take that lightly, right? Right. So, did anybody get hit by the context window limit? If you're posting a lot of text into the input, you may get an error message. Did anybody see that? Yeah, there was one. Yeah.
Yes, so I don't think, I don't know if this is what you're saying, but when I asked you the second question, I got the internal error has occurred. Is that it? I got.
I think. Oh, I think that's not the error. That's probably the internet connection. But if you keep passing a lot of like long documents to it, sometimes you see an error message saying the token limit is exceeded, and that's because of the limitation of a smaller model like Gemma. As I said, it has 8,000 token limit, right? So you can't pass a huge amount of information to it. But with bigger models, you can. Typically, the context window is much bigger. Right. So maybe this one, I would like to maybe get someone to answer this question. So, would you provide the answers to patients, or would you make healthcare workers double check the answers, or would you use the answers in other applications like education or training? Okay. Yeah. Tresor?
Awesome, thank you. The short answer is no. I was playing around with Gemma as well. I was testing the 2 billion, I think 9 billion, and then the bigger one, I think it's 27 billion parameter models. So I asked it the questions. I agree, this is a very niche question about the list of districts in a town in Congo, which is Kinshasa. So there are 24 districts. So Gemma 2 and Gemma, I think 2 billion and 9 billion models answer that it didn't know the answer, which I like actually. It rather tell you, I prefer getting an answer that I don't know than coming up with hallucination or things that are incorrect. But the 27 billion one answered, it gave actually a list of 24 districts, and I think 18 of them were correct, 6 were completely incorrect. So that obviously it so hallucinates, right, when you ask it questions around actual fact. But I found it quite impressive that you would know about 18 of them. And I would have also, preferred it to tell me like this, and I don't know for sure. And I also did a follow-up question, just telling him like a few of your answers are not correct, to try to see if it will pick up some of the incorrect answer. And then it did pick up 2, and then provided yet 2 more incorrect ones. So just, long story short, no, they're not completely trustworthy. They're getting there, but they're not 100% yet.
That's a great answer. Thank you. Anyone else?
I think I'll use the answer. I'll present the answer to the healthcare worker in a way that it sort of initiates some sort of discussion between the healthcare worker, maybe, and their colleagues, even initiate like a step to verify the answers, maybe by doing a lab test, but sort of present that answer in a way that the issue initiate like a next step into the process. Yeah.
Yeah, so having a human in the loop. Yeah. All right, thanks. Thank you for trying and playing with the models and sort of thinking about these really, really important topics. You know, I think I myself don't have very good answers to all of these questions. I think it's something that we have to continue as a group, as a community to figure out. And obviously there's a lot of considerations around security, policy, you know, regulation that we really have to pay attention to. So it's a continued effort. Right, so I'm going to talk a little bit more about some of the work we have done with Gemma to answer sort of questions around health guidelines. So we have been playing with the models to try to see how the model would understand something like the WHO ANC guideline for pregnancy. So there's some use cases around this, right? Because you could try to provide explanations for patients, for education. You could help use this to improve the training for health workers. Maybe you want to have quick access to relevant information. Maybe it's not directly answering something, but finding the correct context in this document. And then critically, you might be able to be deployed locally or even on mobile. I think the same considerations here, right? Accuracy, reliability, patient privacy, security, compliance, and then human oversight. So these are very important topics. So what we have done was that we created a notebook, a collab, and then we were considering sort of, okay, we want to see how Gemma performs against these guidelines. But what we really need to know is how to have like evaluation data to be able to have a benchmark to evaluate the performance. But we don't have any good data in this particular case because we only have the PDF document, which is a guideline. So we were thinking, oh, maybe we can generate some synthetic data and use that to evaluate Gemma's performance. So instead, what we did was we actually passed the guideline content to Gemini, and then we asked Gemini, can you generate some answers, some questions, and some model answers as a evaluation set, right? And then we wanted to use that set of questions and answers to ask Gemma to see how Gemma performs, right? But there's a problem here. The Gemini's answer, are subject to the same problems because we don't really know if those answers are 100% correct. So what we did was we asked the human expert. We had a clinician who checked all the answers that were provided, questions and answers provided by Gemini to make sure everything is correct. And then we used that to evaluate Gemma. So that became our final eval data. So again, even for evaluation data, it's very important to have someone to double check, have someone who's with clinical experience. So I'm going to show that collab. You can, again, go back to the same repo. The collab itself is the ODHS Day 2 Track 1 05A CL1, standing for Code Lab 1. It is Gemini WHO ANC guidelines eval data generation. So if you haven't scanned the QR codes, I'll give you a second to do that. Otherwise, I'm gonna just really quickly show you what that code lab is about. So this is my collab. I'm sorry, I'm having some internet issues. I was not able to run this just now. But essentially what we're doing here is we are loading up the PDF file of the guideline, and then we're selecting the latest Gemini model. We are providing some of the sort of setups to, break up the tokens, and then generating the answers and questions. And then I want to show you the prompt, which is the most important part. Right. So we're asking Gemini to generate multiple choice questions based on the provided extracted text corpus, which is a guideline. Right. So for each question, there's 5 answers, and then Gemini needs to provide the correct answer. And then we also ask the Gemini to generate the short form answers. I think this was again mentioned yesterday. A lot of the data eval that has been happening is kind of, multiple choice questions. But in reality, you would never, patient doesn't come to you and say, do I have A, diabetes, B, hypertension? That's an insane scenario. So it's really important for us to evaluate models in a sort of more realistic way. So here we have tried using sort of generating some of the short form answers from Gemini, right? So we also asked the Gemini to sort of spread out the answers from the guideline, because we want Gemini to cover different aspects of the guideline and not just generate questions and answers in a specific field, which sometimes would do. Right, so maybe I will show you sort of the model answers and questions. Yeah, so this is quite small, I'm sorry. Yeah, so this is a CSV file actually, but I'm just presenting it in a text editor. So basically you have, so this is one question or answer. It was asking, is a question about nutritional interventions. The question is, which supplement is routinely recommended for all pregnant women to prevent anemia and neural tube defects? And there are 5 answers, A, B, C, D, E, and the correct answer I think is A, which is iron and folic acid. So that's something that Gemini created, and then we had a clinician double check, and then we decided that it's correct. So we were using this question to evaluate Gemma in the next step. Just to show you maybe another example, maybe the SQA questions. So in this case, we were generating questions such as, what constitutes a healthy diet during pregnancy? And the answer that was generated was pregnant women should consume a variety of foods such as fruits, vegetables, whole grains, lean protein, and healthy fats to ensure they receive adequate energy, protein, vitamins, and minerals. And then we had a clinician to check this answer to see if it's correct and is according to the content of the ANC guideline. And we decided we can use this question and answer for the evaluation of JAMA. Right, so that's that. So what did we do next? We used this data set that we had to evaluate JAMA. I think do I have enough time? I have time. So I'll show this code lab. Here we go. So we kind of asked JAMA to answer questions that were in that data set, and then we were marking JAMA based on the result. So I'm just going to show you the prompts we used. Yeah, so this is for the MCQ. So your task is to carefully read and question and analyze each option and choose a correct option from the 5 options. And then for short form, we have this prompt, which is the task is to carefully read the questions and generate short answers based on your knowledge as a WHO expert. And you should provide a short answer between 10 and 20 words. Please refrain from giving single or 2-word answers, etc., etc. What we found here was that Gemma was actually quite good at guessing the correct option from the multiple choice questions. So Gemma 2, I think in one evaluation, it was giving over 80% of the answers correctly, and it was insane because it's a very small model, and we're not even saying specifically, we're not even giving the guideline content to Gemma, but it was getting a really, really good result. So that was a little bit surprising, but when it came to sort of short form questions and answers, the performance was much worse. Gemma was giving like sort of very short answers and sometimes missing very important points or not exactly accurate. I'm not sure I have the file. Let's see. Yeah. That's without context. Just the naked model, yeah. Yeah. Later on. Yeah, well, I'll show that. Yeah, so in this case, I'm sorry, I should have probably used a better formatting, but here, you can see the Gemini answer for the first question is a little bit longer. It's a bit more complete about what needs to be included in a healthy diet, where the Gemma answer is much shorter. It just says, balanced diet rich in fruits, vegetables, and lean protein while limiting processed food and sugar drinks. Please let me know your questions. So that's a little bit less complete than Gemini's answer, but it's still reasonable. So we had a clinician to evaluate all the answers. We found that in general, Gemma's score for these kind of short form questions and answers is much, much lower than Gemini. It's around, I think it was nowhere close to 5. Out of 5, I think it was like 2 and 3, between 2 and 3. Right, so to Matt's question, it's a very important question. We are really just doing very simple questions and answers to a model that has not been adapted at all, right? So that's a model that's been trained using very generic text data that's available in the training data set. So it's kind of surprising that it's performing okay. Yes?
When generating the question and answers for short question answer, short form, did you mark certain words as keywords so that if they're responded by the model that is being evaluated, did you mark that?
No, we didn't have any of that kind of sort of syntax highlighting or emphasizing, no. But it's a good question. I imagine if you really want to provide this kind of information to health workers, you probably need to say, this is the important point in this question, in the answer, and they really need to provide that to the patient. Yeah. Right. So, so as we have seen, Gemma's performance was sort of a mixed bag. So how do we improve model performance in this case, right? Because accuracy and reliability are really paramount in this setting. So one thing that Matt mentioned is that we probably should pass the context to the model, because then you'll know what we're asking about in the context ANC or a different WHO guideline. But Gemma's context window, as I mentioned, is very small. It's a few thousand words, and we can't pass big documents to it. So what can we do here? I think there are two options. There's two sort of common ML techniques for this kind of improvement. So one is called fine-tuning, and the other one is called retrieval augmented generation. So I'll go into both of them very quickly. So what is fine-tuning? It's actually really simple. You just keep training the model with a bit more data. That's all. But the trick really is having really good data, high quality, domain-specific training data. You have to pass that to the model to continue to train it, to make it get better and better at this specific data set and this specific domain, right? This is something that's available, that you can do with open models like Gemma, but it is relatively expensive computationally. And also the challenge really is that sort of typically we don't have good data for this kind of task. But there are some tricks you can do, you can use. One trick is called low rank adaptation, or commonly referred to as LoRa. So what this is basically a sort of way to make it a bit easier to fine-tune models. You know, instead of trying to update all the model weights, you know, we're talking about 2 billion parameters or 9 billion parameters. We are using sort of a much smaller, well, two much smaller matrices and update the ranking of those matrices. And the kind of intuition behind this really is that when you are fine-tuning models, you are really making smaller adjustments in certain directions. So you typically don't really need to have like a full model weight updates in that original weight matrix. The second approach is called retrieval augmented generation. So we know that JAMA's context window is not big enough for the entire WHO ANC guideline, but it's probably big enough for a few paragraphs or a page of it, right? So how can we make use of that and try to provide more context to the model to improve its performance? So the way to do it is to essentially divide the document into little chunks, and then when you're querying the model, you can sort of use a library to, like a similarity, like text similarity search library, to figure out which one of the chunks is the most relevant to your specific context, right? For example, if I'm asking the model, what's a good diet for a pregnant woman, I think the model, well, instead of directly asking the model that, we should first of all try to find out which part of the ANC guideline has the most relevant data, and then say to the model, given this chapter of the ANC guideline, or given these two paragraphs of the ANC guideline, which would include relevant data, what is a good, a healthy diet for a pregnant woman, right? So this is something that obviously requires another step of dividing or chunking the document and then querying the similarity API before passing the prompt as well as the context to the model. So looking at the diagram on the right, I'm trying to sort of convey the idea. If you're trying to pass the guideline content with your prompt to the model, it exceeds the size of the context window, right? But if you divide the guideline content into smaller chunks, and then you take one chunk that's relevant to the part of the guideline, and together with a prompt that fits in the context window. So you can just ask JAMA in one go. Right, so which one of these do we use? There's no right or wrong answer. Both are extremely valid approaches, but they are a little bit different. So fine-tuning, after the model is fine-tuned, typically you have, well, there's no additional latency, right? Because you don't have to do another sort of text retrieval and the similarity comparison before passing the query to the model. So it's a bit quicker. But the difficulty here is having high quality task specific data. RAG is good because it gives you an opportunity to ground the answers, right? So instead of blindly trusting the answer provided by JAMA, you can actually refer to the paragraph in the guideline that JAMA is providing the answer based upon, right? So that is what we call explainability, and that's really, really important, especially in the medical setting. You want to provide an answer to the health worker or the patient, you also want to say, we're providing this answer because of this part of the ANC guideline. And then RAG is also a bit easier to update with the latest data, because once the model is fine-tuned, it is fine-tuned with the data that you have. If there's another version of the guideline, for example, you have to re-fine-tune the model, and that can be, as I said, costly. But if you're doing RAG, all you have to do is to update your vector store or update the sort of chunked document so you can pass the latest context or updated context to the model. So I'm going to just go through this code lab with everyone here really quickly. This is what we have done trying to evaluate Gemma's performance against the guideline using RAG. It's actually really, really simple. There's only two things I want to show in this code lab. There's a lot of setup, a lot of utility functions. But one important thing is that we are splitting the document into smaller chunks. We use an API we use Lantern's document API to do this. And then you can see this is an example of one chunk of the ANC guideline, right? This is chunk 20, I think. You see, this is a much smaller chunk than the entire guideline content. And then when we are asking when we're asking Gemma a question, we use this library called VICE to compare the question with all the chunked documents that we have, and then find the most relevant part. And then instead of just asking Gemma to answer a question, we're asking Gemma to answer the question with the retrieved context. So that's part of the prompt, right? So again, in the nutrition example, we're saying what is a healthy diet, and then we're passing the paragraph about healthy diet from the guideline together with that question to Gemma. So it's kind of doing a lot of the heavy lifting for the model, because you're saying that you really need to answer this question from this context. And the same thing with the short form answers. We're asking Gemma to answer a question, provide a short answer, given the retrieved context, which is part of the original ANC guideline. So we have found that the model's performance is much better than before, obviously. That's the end of my presentation. Thank you. Oh, actually, that's not the end. There's another slide. So really, because I have 5 minutes, right? So 3 minutes now. Really quickly, conclusion, I think my only one conclusion sort of advice to everyone is just to keep exploring. There's so much free content out there. Especially check out the Gemma cookbook. It's a very big repo with a lot of content. So the code lab, the example app I was telling you about, where I wanted to build an Android app that runs Gemma offline. So that's from that cookbook as well. And then there's a book I want to recommend to everyone. This book is called The Little Book of Deep Learning. It's written by Francois Floret. It's a very, very small book. It fits in your pocket. It's a little bit bigger than the phone, but it really fits in your pocket. It goes through all the important topics of deep learning in a way that is really, really easy to understand if you have a sort of STEM background. If you have studied engineering, science or engineering background, this book would be very easy to understand. So that's all. Thank you. I hope you enjoyed it.